Welcome to Rubber Duck Engineering.
Guess you're doing the intro tonight.
On tonight's episode, we will add the ELO rating system to our Battle Royale bot algorithm thing. It's going to be
Not the ELO rating system.
There's a small problem, which is that the ELO rating system is for 2 players, and we have a 5-player game. But we'll figure it out somehow.
I think that others have faced this exact same problem and have somehow persevered.
It must be possible. How could it be impossible?
But even if we did it for 2 people, I think that was. Anyways, it's nice to see you, Adam.
Good to see you, Eric. How are you?
I'm well, tired. I confirmed to myself for the maybe 3rd time in recent history that if I have chocolate after about 3 p.m., I cannot sleep until about midnight. And so last night I had chocolate for dessert, and then I did not sleep until about midnight, and that was a problem. So I'm running on fumes today, which is I have too often said in our video call, but I'm gonna make it through.
Last night I had a bowl of chocolate chips that I was eating while watching YouTube, and I had the foresight to not actually finish the bowl of chocolate chips. I recognized that I was done, and I put the extra chocolate chips back. I was very proud of myself.
Gold star.
Yeah. I'll take the wins that I can get. Let's put it that way.
Excellent. So yeah, ELO. I remember ELO from when I was a kid, and we would have ELO ratings in, chess club in Kansas or whatever.
Well, I think it's an interesting trend. Like many games use ELO under the covers to do intelligent matchmaking, but many modern games don't tell you what your rating is, even though the game itself knows. Whereas in chess, I've been learning a little bit about the chess world. Like everyone wears their ELO, like their name tag. It's like the 2 things you know about the person is like what their name is,
handle.
Yeah, what their ELO is, and like what country they're from. Like that's like the key information.
Yep.
And it has this funny like ego effect on people. Like people become very like attached and prideful of their ratings, and you can tell that they sort of, or maybe they're like afraid to play games because they might lose and the ELO might go down or something. I don't know that you observe that.
Oh, I totally observed that. Well, it helped again growing up in Kansas because we didn't have that many events where we could get actual like national ELO ratings.
Oh, did you have like ELO like within your own club, and then when you went to like registered events, somehow it was a different system?
Yeah, there was like statewide ratings, which were like, pretend or whatever. So this was many, many years ago. But I just remember meeting people who like grew up on the East Coast and went to a club where like the weekly game night, had actual, ELO. It adjusted your like national score or whatever. So, hello, Jock 2S. And yes, it is a banjo next to the guitar. It is a 5-string banjo.
I've been trying to get Eric to play a musical intro for the show the entire time we've had the show. And someday this will happen.
Yeah, there was a very musical phase of my life. It was many years ago, and the musical instruments have mostly hung on the wall as decoration since that musical phase.
They're beautiful, by the way. They're really wonderful wall hangings.
Thank you. Maybe Hal, it's wonderful to see you. A lot of games use derivatives of ELO in matchmaking. That's what I've heard. I remember looking into like League of Legends, like because they have like it's like 10-person vs 10-person, and somehow they have to do matchmaking. And I just remember learning that like they couldn't actually use ELO because it was a mano a mano or a 2-person kind of thing.
Well, I think ELO isn't really designed for the scenario where the game has some randomness in it, and so you have to adapt the fact that in some games even the best player in the world playing against the worst player in the world, the worst player will win 20% of the time. It makes a big difference.
And then how much do you adjust ratings and stuff like? Do you adjust ratings? And I know that some games use ELO derivatives under the covers, and then they also then throw like another layer of complexity on top to like hide what's going on,
or to give you like a number that goes up over the course of the season and then comes down or something like a bonus pool.
Maybe Hal says he or she went down the the ELO rabbit hole a while ago. I hear you. There are a ton of considerations like skill, latency, and a whole bunch of things. Exactly. Yeah. Yeah. No,
Yes.
like in these games where you like drop, like what happens, or where you have bad latency, what happens?
Yeah.
Yeah.
Yeah. The gold, silver, platinum also gives you this, because when people go down, they feel bad. So a lot of times I see this gold, silver, platinum thing. It's once you achieve gold, you can't go back to silver. You like lock it in for at least some period of time.
Mm-hmm. Yeah. Cool. So I also heard a little bird told me that you did some programming off air.
Yeah, I did a little bit of hacking on our project. If you want to pull up the code, we can take a look at it.
You didn't see me. Whatever, it's matter.
What does this hand gesture mean?
It was like tisk tisk or whatever, you know?
Tisk, you wrote an entire Ren interpreter off screen. All I did is
there might be some pot kettle going on here.
I just made the leaderboard pretty.
You wrote an entire Ren. Okay, let's see. I did before the show on my Mac run this, and I love that we live in the future where that's possible, where I can easily switch back and forth between computers. What? No target?
Oh no, it's mad. Oh, you may need to close this and reopen it because... Oh, maybe I messed it up. There was a bunch of... You see how it says Lambda battle?
Yeah, I originally named it that.
Yeah, so I tried to go fix all of those typos that were buried throughout the project. And I missed some, or maybe you have like some local files that aren't checked in. But if you search for...
The easiest way to fix that actually is to just... We're doing it live here, folks. Is to actually go just remove the win directory, because Flutter has this cool feature.
Well, I wonder if it's in your Visual Studio Code, in your IML file, actually.
That could be too. Like, not in this one, but like BSC.
Oh yeah, I would just grep for the misspelled word inside this directory.
Lambda?
No, I don't remember. Anyway.
No, it's okay. We're still doing it live. Because we do kind of need to figure out how to run, unless we want to run it on the web.
So it will repopulate your Windows directory just by doing this?
Well, I didn't actually do it, but if you delete the Windows directory or any of the like template directories like Mac or whatever, and then Flutter create dot, meaning the current directory, it'll just spam out the template on top.
That's neat.
I feel like you may have added it. Well, anyway, this has existed for a long time and is very useful for when
something gets corrupted or...
Yeah. It's funny, actually back when you were on the project, right before you left, I think we swapped from we had this big swap between when like Flutter contained, and like we booted into Flutter and then like had the app versus we like booted into whatever. I'm not making any sense. We made it possible to embed Flutter in other things. All right, but that was not what I was doing.
Did it run? I saw it said build and then...
Where do you see Lambda?
Right there.
Well, this is how I mistyped it. Lamb.
There's no D.
Oh, there's no D. It's llama.
Yeah, so you should search for that string and see where it occurs. I think I eradicated it from the Git repository, but you might have some locally on your computer.
Okay. We're going to try. Talk to the people.
Anyway, so I say what I did. So the main thing I did is I made the leaderboard pretty. And I also changed the scoring system slightly. So before it used to get, if there was a winner, that person would get 1, or that agent would get 1 point. Now, if there's a draw, all of the surviving players divide the 1 point among them. So if it's a 2-player draw, they each get 0.5. If it's a 3-player draw, they all get 1/3, etc. And the other thing I did is previously we had to hard code the agents that were going to be in the battle. Instead, what I did is I made the agents register little factory functions, and then I picked 5 factory functions at random with replacement. and then instantiate those agents and put them into the field to battle it out. And then the third thing I did is, so before we had an agent called Seeker, and what Seeker would do is look around for the closest agent and head right for them, and then try to get them. And Seeker was really good. And so when I did this, Seeker would get really the high score all the time. And so I tried to think, like, what would an agent be like that would be better than Seeker? So I made an agent called Opportunist. So what Opportunist does is it acts like a runner. So it runs away from everybody unless it's right next to another agent. And in that case, it will move on top of that agent. And so what happens is the Seeker goes and tries to get near to the Opportunist. And right when the Seeker is one step away, the Opportunist will quick step on him. And so the Opportunist just like completely dominates Seeker. And so in the current way of scoring things, the Opportunist is the highest scoring agent. And I think it'd be interesting to figure out if once we have a good scoring system in place, like can you or can we or can anybody think of an agent or design an agent that does better than let's say Opportunist, or does better than the other agents?
I actually looked very briefly at that, and then I was feeling tired this weekend because I suspect that one could write a much like more complicated agent that did like way better. Because we don't ever like look to see if we're going to get eaten next turn, for example.
Yeah, so like there's always this question in these kind of games is like, how do you solve the metagame? Like, how do you figure out among all the agents that could be written, like which is the best agent? And so one very basic strategy for solving the metagame is you just keep trying to make better and better agents relative to the agents that you know, and then look for weaknesses in the good agents. Oh, the other thing I did is I made the agents so they could custom paint, so they each can draw custom UI, so you can visualize what they're doing. So do you want to turn down the speed so people can see more what's going on? But you can see the leaderboard there. So Opportunist is the best agent that we know of so far.
The speed is...
Just search for milliseconds in here.
Oh, wow. 50? Not too much.
Oh, like 200 or something. Like, I don't know. Yeah, so this brown agent is a agent called Fixate. So Fixate will pick a direction and then keep going in that direction. And so it draws a little line to show you what direction it's fixated on.
And which one is the purple one?
The purple one, I think, is
we could look.
I'm not sure.
If we look at agents, we just search for purple. It's random mover.
Random mover. So blue is Seeker. So it draws a circle around the agent that it's trying to go get.
Oh.
And teal, I think, is Opportunist. So it got close to Opportunist, and Opportunist ate him. He's gonna eat. Yep. See, he just ate the brown one. The brown one is fixated.
So Opportunist is quite dumb.
Well, so there's another interesting game, which is this. Some of these games have if you give enough points for draws, often a good strategy is if the opponent will draw with you, to try to aim for a draw. So Opportunist, if you are not trying to hurt Opportunist, he'll happily make a draw with you. But if you come close and you think he thinks you might try to eat him, then he eats you.
Huh. That's interesting. Yeah, I think it'd be fascinating to write a better agent. But that was not what we were going to do tonight. Tonight, we were going to add
try a better scoring system. Okay. So maybe we should start by looking at the equation for ELO.
Okay.
Well, we got a complicated question here. Do we know that the Opportunist's ability to step on the Seeker is a skill superior to the Seeker's ability to step on the agents? So this game is turn-based. So if you just make an experiment that just has the Seeker and the Opportunist, the Opportunist will win almost all the time. Because the Opportunist is running away, the Seeker never quite catches up. And if the Seeker gets close, then it gets eaten. And the Opportunist can step on any player. The Opportunist doesn't know anything about the fact that it's the Seeker. Just anybody who gets within one square of the Opportunist will strike. And we can look at the code if you want to look at the code for it.
Yeah. So opportunist.
So it finds the closest position, and it tries to. It says, if I have a legal move that will put me on top of the closest thing, make that move. Otherwise, try to find a move that goes as far away from the closest thing. So it's a pretty simple algorithm.
What's this get positions piece type king first? So this is like where, this is assuming it has one king.
Yeah. I mean, the game engine is very general. Like any player can have any number of pieces, but at the moment, each player only has one piece, which is the king.
Okay. And then get closest opponent from us of this type of piece.
Mm-hmm.
Okay. We may have overgeneralized this, but such is software. And then right, if we find a closest opponent, or I say if we don't find a closest opponent to go to, then we just move randomly.
Mm-hmm.
Otherwise, for the move within our legal moves, if one of them would squash that opponent,
mm-hmm.
then we take that move. Otherwise, we find by distance to target where current distance is greater than best distance.
I mean, we prefer bigger and bigger distances.
Yeah, makes sense. Okay. Yeah, so this is the runaway behavior. But if you get close to me, I eat you.
Yep.
Okay.
I don't know. Like, I think it's an interesting challenge. Like, how do you...
Yeah.
This algorithm is a little bit smarter than the other algorithms we have. So, like, I think it's an interesting challenge. Like, how do you write an algorithm that beats this one and beats all the other ones?
And you said you added the ability to paint. Oh, yeah, right here. So now your agent can override paint.
Yeah, you can get creative and paint whatever you want.
I see. So
if you call super.paint, it'll just paint the normal thing. And then I think this is probably Seeker. So if Seeker has a target, then it goes and draws a circle around the target, so you can see what it's going for.
Do other ones paint as well?
Oh, yeah.
Fixate does too. If we have a favorite direction, we paint a stroke in that direction. Make sense?
Yeah, this is not the best paint code. I was originally trying to draw like little arrows and something complicated, but I suspect you could make this much simpler. I eventually like scoped it down to a line because I could do that one correctly.
All right, so shall we try down the ELO rabbit hole?
Yeah, let's do it.
You read the Wikipedia article?
I read the Wikipedia article. Do you want to pull up the Wikipedia article? It has a bunch of equations in it.
Let's see what we got. Rubber duck engineering. ELO. Electric light orchestra. No, this one.
If you scroll down to mathematical details, that will help us. So the first thing we need to do is we need to associate a rating with each player or agent.
Okay.
And then we need to, when two agents face off against each other, and here we're having the like 2 versus 5 problem, we need to compute the expected outcome, which is this EA value. Mm-hmm. So something about the difference in the ratings, and then some a little bit of math. And then if you scroll down a little bit more, you'll find the rating update function. So the rating update function is that. So that the new rating for the player is their old rating plus the actual outcome. The difference between the actual outcome and the expected times K, where K is this parameter for how quickly you want the ratings to change.
Makes sense. Seems pretty straightforward. All right, so this is so your rating is some value, and maybe it's 0 to 1, or maybe it's spread across some scale or whatever. Mm-hmm. And this is the expected outcome. So the expected outcome for A is 1 plus 10 to the rating of B minus rating of A divided by 400. Mm-hmm. And similarly, expected score for B is this. Okay.
Yeah, so I think like a typical ELO rating is like 800 or something. Like that's a.
I think they 400 value.
I think they just tune the constants in the equation to get nice looking numbers for human beings.
Okay. And then so your updated rating is now your previous rating plus this k value times the actual outcome for you minus your expected outcome.
Yeah. So when I was playing in competitive events that use a rating system like this, the events would advertise the K value, and that would be like how serious an event is this? Like if the K value is very low, that means it's competitive, but it doesn't matter too much if you win or lose. Whereas like the World Championship had a really high K value because they thought people would put a lot of work into it and really try hard to win.
I just remember, like back in chess, because we were in Kansas and we got to play all these non-nationally ranked games. When we go to the national tournaments, we got to take advantage, or this is what our coach said, we got to take advantage of the fact that your rating moved a lot when you hadn't played few games. It was like the first 50 games or something, your K value or something was higher. I don't know that it was K value. And that was somehow good for us because it meant that we weren't like the folks who had gotten better slowly over time and their ratings were slowly still trying to catch up. Ours could like jump up quickly or something. I don't know.
Yeah, I think in all these events, like the more rated games you play, the more accurate your rating is. Well, should we try it? Should we try it?
Yeah, this seems eminently doable. Why the number 400? But we'll see.
I think so. Yeah, they're trying to make like 200. They say in this paragraph that's on top here, a rating difference of 200 corresponds to a 75% win percentage or something.
Okay, and maybe that's part of what that magic is. Okay. So we got to hold the ratings somewhere.
We just put them on the agents. Like
make the agents static.
They now get factored out.
I see. Oh, sure. Then we can hold them on the agent. I don't know if it's cleanest, but that'll work.
Oh, so they get created for each game. So maybe we need a map from like type to rating.
That would make sense. Well, here's this game history. This could include the rating, right?
Oh, that's a good idea. Yeah.
So final map. What's string? Is that the like agent name?
You can just do type. Oh, string is the agent name. Sure, you could do a string. That seems fine.
String to double, and this is rating. I gave you a link, right?
I think it's when you restarted to fix the Lambda thing, it went away.
Oh, I can try to do it in a second. Okay. And so we presumably don't want to look this up directly because we need like a default value.
Well, I think we should start writing some of these equations from the Wikipedia article, like the function that takes two ratings and gives you back the E value.
Sure, okay. If you give me 2 seconds, I will share you the new hotness.
I don't know how we're going to handle the end player thing. We could just change it to be like a 1 versus 1 to start with before we figure out how to generalize to end players.
Yeah, I don't know. I mean, we can look up a different ELO, but I think that might be a longer session, maybe with more preparation. Okay. So here's E value. And this is double 1, double 2. Oops.
And then I'll write the new rating function.
This is 1 divided by 10. This is like 10 pow. I don't remember.
Score.
10. This is going to be 2 minus 1.
So this should be the current rating. Okay, so we need our K value. I suggested 16 as a K value. value times actual score.
We're able to write on the same screen. All right, and this is not Rust, so we have to use returns.
Yeah. It's so funny how you get used to these little like syntax economies.
My poor little brain can only handle so many languages.
So I'm going to rename this for you to
1 plus. Yeah, okay, that makes some sense. Okay, sure. Expected score makes sense. You can call it AB if you want.
This is like my rating. Which one is my rating?
Yeah, it's like mine or other or something. Sure, and then it's other minus. I apologize to everyone. This is flipping, but
okay. The opponent goes first.
Mm-hmm.
The opponent goes first. Okay.
Okay. New rating, current rating, score, expected score. Okay, this looks reasonable. And now we have to get like double current rating. String.
Yep.
And this is then going to be getting dot.
Square brackets.
Default get or something. Oh, I see. You're just going to do that.
I use the null. I don't know what a good initial rating is. Maybe like 1,000.
I think in chess you get 500, but I have no idea if that's good, bad, or ugly. I don't know what the reason there is.
Okay.
Okay. And then this is like, well, I see. So record game is now going to do it.
Mm-hmm. So we saw this like how many players thing. So maybe
I don't know how you do that. I think record game may just only do this when you have 2 players.
Okay, so you can say like if gamestate.players.length is equal to 2.
Yeah. Then we do ratings.
Okay. So then update rating. Rating for 1, 0 relative to 1.
Oh, this is kind of cute.
What is you looking at?
I'm just looking at how people have thought about multiplayer ELO. I have no idea if this is good, bad, or ugly, but this individual suggests that at the end of the game, you just rank all the players by performance. And then you pretend that they won against the person below them in performance and lost against the person above them in performance.
Okay, that's sensible.
Yeah, seems reasonable.
So the expected score of who won? Oh, there's going to be a problem here. So we don't know when we record a game state, all the players that have lost are not there anymore. So we'll need to record that somehow.
Okay. Like on the game state. And like if you end up wanting to sort them, you're going to need to like how long they lived.
Well, let's just do the how long they lived.
Right.
We could do that. So maybe on the game state,
you just have a death time or something like that.
Or just accumulate them in order in a list, like in the order in which they died.
Sure, that's fine.
Yeah, so let's go to game state.
Just have like death order.
Yeah, if you go to game state move, then
player died.
Yeah, we gotta add them to like a
Record death.
like dead players.
What is this player died? Oh, I see. We have to like figure out what are the ones. We could have had multiple players die in this game. Oh, I see.
Only
No.
one at a time.
The way this is written, multiple could have died, but that seems. But okay.
These are new players. These are players. Players. Let's start from players.
Oh, you're doing something different here.
If a player died, you just add them to the list. You just say add.
Oh, you have a dead player somewhere? Where's your dead players?
I added it as a statement.
Oh, I see. Oh, okay.
But we need to find the dead player. So we need to say for player in players if player new players and player and dead players. Oh, you know what? We can just do it up here. Players alive, add them to there. Otherwise, add them to the dead players.
Okay. Makes sense. Okay. And now it was somewhere else that we were dealing with this, and we need to write them down. It was like record game here.
Right. Right. So now we have a bunch of dead players to work with.
And we have them in order. So we could do this simple ELO thing, which why not?
Sure, let's try that.
We're sort of cheating a step, but that's fine. So now this is like, we have to figure out how many players are alive. Oh.
Because they all tie?
Yeah, like, so those players get a draw.
Okay.
Right, so like record dead players as losing against the next dead.
Right.
Record last dead player as losing against both alive players?
Probably
Probably
a random alive player, maybe.
And then record alive players as tying.
As having a draw. Yeah.
Do they all draw against each other?
Maybe we could just record them in a cycle. Like they could, we could like select without replacement from the alive players and form a draw, like a ring of draws.
Right. It'd be terrible.
The other thing to be aware here is, I think we want to do all of the score updates. Do we want to do them all atomically, or do we want to do them all in order?
How could you? Oh, in case you have multiple instances of the same algorithm running, because you have multiple
like,
seekers.
When you update a rating, like if I play against you, there's like a certain number of points at stake, and you want to make sure that it's zero sum, that we don't get more points created or destroyed. It's like you want to transfer the points from the winner to the loser. I think that's fine. You could just need to do the calculation that way.
Okay.
I think we probably start with the losers, start transferring their points all the way up to the winners.
Okay.
But you get a different answer than if you start with the winners and go the other way.
All right. Let's. So okay, 4-player or dead in game state dot dead players. Grammar. Do we have a record rating? We need like an update rating. Update.
Yeah, you can need 2 players, right? You need like void update rating.
Yeah.
Winner, player, loser, right?
Yeah. Do we have a
You actually want to make this an index because you're gonna have to get the next player
Correct.
in line. Maybe that's like a fold reduce kind of way of doing this. Like
probably is. I think this is okay though. Index I is less than length I plus plus.
Mm-hmm. That's good. So I want to say update rating of their I.
This actually should be like -1 here.
Yeah. The winner. It's the other way around that, right? The winner is the one with the larger index.
Mm-hmm.
Okay.
Yep. We can just make that clearer in the code by just doing this, right? Winner, var winner.
Mm-hmm.
Okay. This thing.
Okay.
Don't we need to say what the stakes of the game were, or is that just a constant somewhere?
That's just the k value. Like we can adjust that if we want, but
okay.
And now we need to start pulling from. This feels like an iterator, like it's a total ordering over the players.
Oh well, but the behaviors are different, right? There's these discontinuities in the iterator.
Oh, that's true. Okay.
Right. So the last. So we now need to take the last dead player.
The winning players is like list from game state.players.
Mm-hmm.
We're going to start pulling from this at random.
Why random? I guess random is better than like whatever order they were added. But where
they were just added in a random order, so
that's fine.
We just pull them in from the order that they're in.
Well, we should, if we're depending on the fact that they were added in a random order, we should document that, or we should just randomize them here.
Can we just say like winning players?
I think it's shuffle.
We need to pull off the first one, right? Like the
winning players dot first.
The least winningest.
So these we actually do just like one. So this we only do if there's more than one winner.
Is there a way to like take the last one and
we should do this first part, right? We do the update rating. This is game state.
Right. The loser is dead players last, right? This is like winning players first. Okay.
And then this is like if winning players dot.
It's the same loop here.
Greater than 2.
In the loop will do that, right? Because if it's not,
yeah. Uh-huh.
Uh,
Well, there's an extra one, though. There's an extra one that's conditional on us getting in here in the first place. Oh, no, I guess not. It's this. You go all the way to length, and you do this divided by length, mod length.
I see. To record the draw, basically. So this is update rating for draw.
Mm-hmm.
This is update rating for win.
Really, these are all live players rather than winning players.
Yeah, that's a good point.
This is one. Let's see.
They all draw against each other. I'm worried that if you have two players, we'll record the draw twice.
Yes, we will.
Oh, so I think it's still length -1. Because it's not like we're doing a round robin to record all the draws against all the people. We're just recording one draw for each of them.
Okay, but then you still need to record. If it was length -1, I see. Well, are we drawing between? We're drawing between first and second, and say there's 3, right? You're drawing between first and second and third. You don't need to draw between first and third.
Correct.
Why not?
You basically you form a line and you just record one draw. I mean, we could form a star and record n² draws.
Why is the first and last only ever drawing once? Say you had 5 people draw. Everyone in the middle draws twice, but the first and last only draws once.
Okay, that's a good point.
I wasn't trying to get you. I just was trying to understand.
Well, another possibility is you could just form a draw among all of them, like you record n² draws.
Yeah, I mean, maybe it talks about this. It does not.
Why don't we record n² draws? Why not? So then they just need 2 loops.
Why is n² draws better than I guess it's more fair. Then the order doesn't matter.
Right. So this is j equals I plus 1.
But it still matters in terms of the last dead player only happens to draw against one of them. So whatever the first random alive player gets an extra draw or an extra win out of this, basically.
Right. And just because we want to create a loss for the best worst player, but that's okay. It's just a sort of
Okay. I wonder if that ordering matters. But anyways, okay, great.
Well, that's why. Yeah, I don't know.
This
is why you always end up with modified ELO. Maybe we need to experiment with this to see if this is good.
Yeah. We cheated past the let's just do ELO as a demo stage. We went straight to advanced ELO from some random dude on the internet or dudette, as the case may be. I have no idea.
This is what happens when you publish information on the internet. It just becomes truth. This is how you do ELO.
Yeah, Tom Kerrigan. I mean, he totally got this right.
Okay, so we still have these 2 missing functions that we need to implement here.
Okay. So this one's easy. It's winner.
Okay. I think these things are going to end up sharing a bunch of code, but
Well, we could write it 2 different ways and see who's right. Winner. Okay. And then we want do we have a set rating? I guess that's what this is.
yeah, I think you need to compute the loser rating too, right?
Well, it should be set rating.
Okay.
this is
Score.
and the score is 1-0. Expected score is 1-0.
No, the expected score we got to calculate here. The expected score depends on their rating. The winner's rating,
Oh.
opponent's rating.
Yeah. Which is the winner expected score.
And the new rating is, I see. Right, the actual score is 1.0. Well, I think we just need this value here. The this is how much is at stake, like the points transferred, because you subtract them from one and add it to the other. It's like the stake.
That's fine.
Points transfer.
Our stake. A little weird that we're deviating, but okay.
How
We're
would
avoiding a
you?
little bit of math.
I'm not sure I understand. Can you help me understand?
Well, like we're just avoiding calling the same function twice, which would make us look more like if we just called the same function twice, we'd look more like the Wikipedia article. We're trying to make the code more readable at the cost of a few more.
My worry with that is because we will write to the score database, we'll get a different answer the second time we call it.
I see. So then we have this other non-local invariant of the fact that you need to make sure you calculate all of your expected scores before you do the updates.
I mean, we could do that by just doing it in two phases and like doing a commit. I think we can also just do it this way. Rating winner. Rating stake and adjust rating for the loser. That's a stake.
It's always true that you transfer points. It's just a question of how many points you transfer.
Yeah, it's a zero sum system. So like if two people can't enter a room and like inflate their ELO, they can at most transfer points between each other.
Okay. Okay.
Okay. And this is exactly the same, except I think the points to transfer is 0.5.
0.5 stake.
Expected score. Actual score. Rating for win. I don't know. I mean, we'll see if this gives total nonsense answer.
Whenever you're commenting like this, it's like it should be.
I mean, we can write little wrapper functions. You want to write like update rating
These
for
should
win?
be constants or whatever. We also should just try it. Although we're gonna have to display this.
Yeah. So if you go to the leaderboard, it'll be easier to display because you'll have this object.
Main leaderboard. Whoops. Where do we go here? Leaderboard. Okay. Player score. This is like their percentage.
Yeah. So we can just change that to. Do you want to show their ELO or do you want to show both?
think we should show both for now. Like for the just the sanity that we could have totally screwed up ELO. This is like percent something. I don't really understand the score part, but
percent, sure.
And then what goes in here? Oh, these are headers. I see. Did you do it down here?
Yeah. So it's like history dot rating dot current rating.
What's e.key?
Oh, enumerating all the players.
I see. So that's like player name or something. I see. That's the player entry.
Yeah, okay. I mean, these are the I'm sorting them by percentage.
Oh, except e.key is string.
Solve.
Have keyboard will type.
I mean, we're getting close to the end of the episode, so I don't want to like.
You don't want to refactor the whole. We are getting close to the end of the episode.
Zero territory here. I don't know. What does that do?
This is supposed to be here. It's supposed to be here. You and I are both getting tired. That's what's going on. Okay. What am I missing? 3 positional arguments.
Just pass in an empty list. You want to start with 0 dead players. Yep.
Okay. Current rating for name. Double. So this would be 2 string or?
Yeah, sure.
Probably like 2 fix or something. Okay.
Yeah, why don't you say 2 string fix and give it a 0? Otherwise, you're going to get like huge decimal places.
Okay. What's going here? Why do we stop? Whoa! Everybody's got a 500.
Yeah. Why don't you
up the speed?
Up the speed and do a full restart.
Full.
Well, just to like the percent data and the ELO data match. Otherwise,
I see. Oh, I see. I have to do a full restart? Or, what's going on here? Aha, this is what's going on here. That's what's going on here. If you have errors in your code, hot restart will not actually try, or hot reload will not push the new code.
Because it won't work. It'll just break your app.
Hey, dummy, we know that it doesn't work. We're not going to push it. What about this little thing here? OmniSharp server is running. That was from when we did C#.
We're just accumulating every language server into your Visual Studio code.
We got all the extensions now. Okay, let's see what we got. Pew, pew. Opportunist. What? That was weird. Why did it go into that mode? Are we like only putting 2 on now or something? We somehow like regressed our.
Looks like we broke the draw logic in the ending the game.
Oh, I wonder if that list that I'm passing is passing in the wrong position. This. Which one goes where? Dead players. Why did I pass an empty list? Oh, that's empty. Is there another place that I passed it? What's the draw logic?
Looks fun.
Little draw, move. Presumably we broke this. New dead players.
Looks fun. Try running it again.
Well, it also it almost felt like it was just like using an old version of the Dark Code or something. Like, I wonder if this is it could have like two. It was running the Llama battle.
Oh, the Llama battle. They were showing the ELO in the table, right?
Like, what's going on?
You're like, why isn't this game ending? This is clearly a draw. Like, it's recorded the draw, but it hasn't moved on to the next game.
What's going on?
Is there any like output, like a exception or anything, or?
Oh, handled timer. No state. Bad element. Record game. Update rating.
Oh, what if there are no dead players? If they all draw, if they all survive, then we don't want to do that last thing.
Okay, so if game state dead players that is not empty. Oh, this is not Rust. I was looking up the song "The Cheat Is Not Dead" for some reason this last week. Whatever that was from, the 90s or early aughts or whatever, when Strong Bad was a thing and Flash was still with us. Pour one out for Flash.
There we go.
Okay, but everyone has a 500 ELO forever.
The ELO is never changing. Okay. Why is the ELO never changing?
What does update rating do? Are we transferring the ratings?
Stake points to transfer. What is the expected score? Current rating.
Current rating player. Oh, yeah, that works. Player.name.
Why don't we log the stakes? Like, what are this?
We're gonna just do this.
Oh, you know what? I bet it's this 1.0, like integer versus double math.
What do you mean?
Or doubles.
More doubles?
Or doubles. Nope.
Let's try walking through it here.
Can we set a breakpoint? Yeah.
Exactly.
Okay.
Okay. So this is about to win.
Okay.
Or we're in the process of winning.
So can we look at the game state? Like, how many dead players do we have?
0.
0 dead players? That doesn't seem right. How many live players do we have?
We're recording the game before 1.
So we're failing to accumulate dead players. So that's got to be in the game update. If the player...
You know we've gone over time, by the way, because my screen has dimmed. Bedtime.
I solved it. The bug was on line 265 of engine.dart.
I was futzing with my screen dimming yesterday. I was like, oh, I don't want to ever interrupt the show. What? Build errors. Impossible. List dynamic.
Oh, okay, fine.
More types.
Insert
More types. Stop types.
We would say instead of passing the new dead players, we were passing the old dead players. So we would compute the number of dead players and then just drop them on the floor.
I feel like someone watching this, watching us be silly and make 90s references.
You have to be from the right vintage. Like, this is always the case. Like, do you want to explain stop dots? I guess we've explained this on the show before.
Oh, like whatever. More dots, stop. There's beautiful YouTube videos explaining more dots, stop dots.
It's a World of Warcraft thing, as I recall.
Oh, what we do? What do we do?
You got your breakpoint. Try taking your breakpoint off.
We got the breakpoint?
I think we nailed it.
We nailed it? We always nail it. Oh, look at that. Look at that ELO.
There we go.
Why are they moving so slowly?
I don't know. But the ELOs are tracking the percentages. So like, and they're not exactly the same as the percentages, which is interesting. But they're,
well, that's what the little thing said is that, you know, they in their little article they're talking about their time to convergence.
Mm-hmm.
Okay. So in our overtime.
I think we're ready to set out the challenge for the community.
Yes.
Which is send us a pull request. Do you want to put up the URL for the repo? Write an agent, add it to the agents.dart file, and the goal is to get the highest ELO. So we'll just add it to the whatever metagame of agents exists at the time, and we'll run, I don't know, 10,000 games, and the bot with the highest ELO will be declared the victor, and the prize will be fame and no fortune, just fame.
You will be forever enshrined on YouTube and Twitch.
Anyway,
famous within the Rubber Duck engineering community.
It's interesting. So Seeker is actually getting a higher ELO than Opportunist, even though Opportunist is getting a higher percentage than Seeker. I think is fascinating.
Is that because Seeker wins more?
Opportunist participates in a lot of draws, whereas Seeker either loses or wins. And so this ELO is favoring things that actually win, as opposed to participating in draws.
We should probably sum our ELO and make sure.
Well, what's happening is when you participate in a draw, like Opportunists will often draw, let's say, with Fixate. And so Fixate has a low ELO. And so that in that draw scenario, Opportunists will lose points to Fixate. Which is like part of the purpose of using ELO as a scoring system instead of just using this raw percentage value.
That's fascinating. Yeah, it penalizes you.
Although it's fluctuating, actually. Now Opportunist has higher ELO. So it's interesting. We may have to run many, many trials to see what the end state is.
Yeah. Anyways, we have kept ourselves and folks way over time. It was wonderful to see you, Dr. Barth.
Yeah, it was great to see you, Eric. And I look forward to seeing everyone's submissions. And may the best agent win. Good night, everybody.
Good night, everybody.